If you were to go to music school, you learn the technical aspect of it. You have a class that you're making music. Obviously, you're expected to deliver projects and all that. And then, separate from all that, you have music appreciation class. And music appreciation is not about, hey, you must like what we're telling you to like. It's not that. It's about how to interpret what is going on beyond understanding how it was made. If you listen to classical music, it's not about forcing you to like why classical music, or not needing to know where Bach was when he was creating all the rules that he made for himself and then other people copied it. That's not it. It's about, you hear movements in the music and then you can understand how it's similar to other pieces of music and what people have over time derived out of it. Perhaps why it's elaborate or complex versus simple, not on subjective terms of why it's good. Okay? So, for example, Juan and anybody else, do you have a game that you really, really, really like?
Yes.
Which one?
I'm a pretty big fan of the Zelda franchise, to be honest.
Well, I hate it. I don't like it at all. Ooh,
All
that's
right.
not true. That's very not true. My God, look at the master key right there. You see,
Yeah, I saw it
don't.
before.
So I, no,
You
blasphemy.
keep it there to remind him of his hatred.
Right. Ugh, look, where's that? I'm the boss key. I'm keeping the master key so other people can.
No, but yeah, I had
No,
a professor before telling me that Zelda is it's not a great game and everything, but yeah,
It's the best game.
Look, it's a matter of taste. There's no arguing
exactly.
for it.
It's his opinion. I can't really influence that. I could
No,
try,
you
but
yeah, you
it's
could
his
wait a
opinion.
second. You can influence it, but you don't need to change it. There's
Exactly.
no need for that, right? It's just accounting for taste is a fool's errand. And I already used the word is. That's already my opinion. When I say something is, like, doesn't mean that it is or that it isn't. I I guess I'm qualifying my experience with it. That's not even, well, I'm being manipulative when I say something is. I try to avoid that verb as much as possible so that I can just say, yeah, from my perspective, however you can qualify it, I consider this has these qualities. So, anyway, about Zelda, if I were to say I don't like it, I might have some reasons as that can construct that opinion from your perspective. I'd be having to show you my mental process. I would have the requirement to show that that argument architected in a way that it makes sense from you living walking a mile in my shoes. However, that would not be as interesting as simply playing it or not. That would be as if you were playing my life, my perspective as a game from your perspective. It's a very weird thing to do. So accounting for taste is it does just doesn't add much to the discussion. You can say, however, that the things that you are experiencing with it would might, as you are trying to grow your expertise in games, might have something to do with your future endeavors. It might be something to avoid completely, and you know through omission it influences you. But I wouldn't want you to make the main qualifier of what you're learning to be whether it is good or not. Whether you, even you yourself, think is good or bad. There is a there there is a design that I'm thinking, I can't say what it is because it gives it away. But playing with Brian Stabile, he's a teacher that you'll have in the future, hopefully. He makes a lot of games. He's working on a very cool game based on High Ally, and he in exploring one design from some silly thing or not, we said, imagine doing the opposite of that, exactly the opposite, and we had to imagine what the opposite was. Imagine if you were to say, let's make the opposite of baseball. Where do you start to say what an opposite to baseball is? Uh,
Does the ball hit you?
right. Does the ball hit you? Are we playing on instead of a diamond, we're playing on what's the opposite of a diamond?
Circle, maybe?
Yeah, I would say a circle.
But
'cause
that would,
it's-
but,
Not like maybe like an inverted circle where you have to play on like the edges of the shape instead of inside of it.
maybe you're playing on a 3D shape instead of a 2D shape.
but you already, but in a way, the offense already plays on the line. It never plays outside of the line, right? So, how do you? What's the opposite of baseball? So it wouldn't even be about whether you like baseball or not. It's whether you start on the foundation of what its opposite is. So you first have to define it. Everything that we're doing here and onward, okay, on a project class or when you talk with one another, I want you to elevate it. I want you to elevate the discussion to not, well, what's my assignment, what's my activity, and what you got to do. Yeah, you do that, and you race past that, run past that, so that you can get to where it's good for you. Not where it is good for you, where you like it. See the difference between me saying where it is and where I say where you like it? Consider what that like contains. Just think about it for yourself for a second. We give you some exercises, and then with those exercises things get tested or created. So today we already talked about the class stuff from last class, right? So today we're going to make a couple of cases here. The purpose of the Google Sheets existence in the context of this class has more to do with what you will be doing in the future than how much of it you get to implement in this activity. You will be implementing some of it in this activity, but only the values, only the data, not whether it works perfectly or not. I will see that data in the Google Sheets. I'll see that. You'll see, it'll be what you enter. It has nothing to do at all whatsoever with what you turn in on the code. Exactly on the code. I'll see some pictures, some screenshots of how you implemented that in there, but I'm testing these two things separately. The purpose of it existing on Google Sheets or some other type of spreadsheet, I want you to align it to the systems thinking that you will be exploring in the future. You're designers in training, and it would be silly to expect that that means something like you're programmers with some design skills, or you're designers with programming skills, or what. A designer benefits a team by contributing based on need, based on resources. A designer makes more general knowledge more useful. A designer can synthesize the different elements, functions, mechanics, whatever you want to call them, into assembles it into good meaning. That's why when they say a designer is a vision keeper, well, it's not that they keep the vision like lock and key, protecting it from anybody having any kind of influence on it. I think what people mean to say there is that the meaning of a game's implementation, the theme, how a player feels it, has been labored by who knows how many people. And it remains a consistent idea. There are games that have some inconsistencies in them. For example, Mario has coins, right?
Yeah.
What does Mario use those coins for?
A life, an extra life at 100 points.
Yeah.
Sometimes power-ups, depending on the game.
On which game, right?
There's a lot of them.
Well, tell me, which one?
I can't remember. I think it's one of the new Super Mario Bros. Games you can get power-ups. I don't remember.
Odyssey?
You
Yeah.
actually know.
They're
Yes,
literally the
yes,
one
yes,
started Mario
yes,
Party.
yes. You know, in Mario Odyssey, you can use some
Yeah.
the moon shines,
you
whatever.
You can
Oh, yeah,
buy a
you can buy
moon,
loads
but
of them.
and you can buy outfits, but I don't remember buying.
You can buy a star in
power-ups.
Mario Party.
Yeah, you can. So you buy stars, you buy an Mario RPG, you buy eventually, but in Super Mario Brothers, a coin, you can't purchase it. It changes it for you. It's almost like your parents go through your drawer, find money, and leave. Well, the tooth fairy basically is what it is. You leave a tooth, and it gets changed magically for money. That's what happens. It doesn't act. The coin itself doesn't act like currency. Okay, that's a different. Currency is an idea. A coin is an example used in a currency or in an economy. If what we're trading with is roses, which was a thing, or salt, that's where salary comes from, etc., then that would be the coin, the element that you trade with. A lot of games don't have proper meaning to the things that they have. They're not consistent. Even though it's a great game, this is an immortal game. Okay? This especially this one. Like it's like, come on, like with pixels in real life, like that's perfect. So this is immortal, but it's not consistent all the way through, right? We use disparate elements to describe different things. So the games that you're using and you're making, there is some kind of cultural or historical reason why are they called gold coins? Why aren't they just called wooden coins? Why aren't they called coins? Why are they gold coins? The reason is to differentiate them and animate them in the screen so that you can tell them apart from the system. There are a number of different reasons why they take the shape that they do. So for a lot of the games that you're going to be working on, sometimes you're going to be working as a programmer, sometimes you're going to be working as a systems person, but throughout you are trying to guarantee that consistency of meaning. That's the vision keeping. So I wanted to decouple the two. I wanted you to start playing with data because we're going to or we did. Last week we talked about the class breakdown and how we organize data, not data, but programming that way. And then we also are going to target that in some very near future, you're going to design and try to, you've heard, of the word balance, right?
Yes.
I don't like that word. I don't like words that make you skip thoughts. I think that you need to earn those words. I think you need to earn it, and it's only in implementation. I don't like balance. I don't like polish. I don't like words that make you skip over the observations that exist in there. If you say balance, what does balancing mean? Does balancing mean like, okay, this character's so OP, we got to remove the entire character? Or nerf it?
Fairness, like equality among options.
Is that always going to be the case? Because that can't really happen all the time. Or that might be provably undoable.
Balance, I think it means you're trying to make options that are supposed to be equal to each other.
So you can't ever find balance, right? So it's just a trying to
Probably
get
not.
balance.
No, unless you made every character the same and just made them different skins of each other, and then you'd have a boring game. But
Oh, you can have a boring game, or it allows for preferences, right? It allows for, there's a psychology at play, so it's not purely
Here's a
mathematical.
here's a balancing issue that modern game designers struggle with to this day, and it is the root of a lot of unique solutions, some bad, some good. How do you balance the fact that there's, in a card game, somebody gets to go first?
Listen,
Like-
we're trying to make something like Tabletop Simulator in this class, in PMP4 a couple of years ago. And it was, first you have to define a card system, like having a deck of 52 cards, so you could do all these kind of UI stuff, like picking them up, sorting them, place them in different spots, making them piles that you can, like spaces for piling or discarding, picking from the bottom, picking from the top, and all of that was so that we could explore design-wise what functions the players do with a deck of cards. Because once you have all those functions, then the majority of the game becomes the rules between those functions. But then Tabletop Simulator was one thing that we were like, okay, don't look at it. Don't look at it. It's like the Medusa. Because the moment you start looking at it, you freeze, and you just have to do everything they're doing. So it's like, know that it exists, and then try to in parallel think of what you would, because you need that influence yourself.
Tabletop Simulator is so versatile. An indie company that I was working with for a while used it to make a virtual paper prototype of their game.
It's almost like Gmod or any other, even Minecraft. I'm making my house in Minecraft so that I know where to put my sweet potatoes that I'm trying to grow.
Wow.
So just to because Minecraft, the purpose of it being that Minecraft has very specific layouts of blocks, and that way I can go to Lowe's and get a whole bunch of cement blocks to know how far apart they need to be and whatever. I could have done that in Excel, but it would be bird's eye view, and I wanted to know how it feels when I look out my window and see the thing. So I need a first person perspective thing. So I'm using a game to demonstrate those things. Look, balance. The purpose of balancing is to maybe have equality of opportunity, right? So I have some kind of, when I start, I am not immediately at a disadvantage. We want to, games are, in so many ways, so many philosophies of ethical philosophies exist in games. There's the idea of how do you make competition fair. It's competition, you want to win, but how do you make it fair? How do you make it ethical? If ethics can be something that you consider, right? And balancing is a little bit of that notion. Balancing is where you look at the numbers, at how numbers affect action, and then you try to make for those numbers not to cancel actions. It's basic. Now that I'm thinking about it, I've never really put it that way before, but I like it. If you have, do you know what a mastery condition is? Have you guys heard that term yet?
I haven't.
Okay.
No.
A mastery problem. Mastery problem is not whether that you are not masterful at something. That's not the, no. It's that mastery problem has it. There's also another one of those concepts is the oh, I forgot. How could I forget that one? Dominant strategy. Okay. So
okay.
you've heard
Yeah,
of
I
that
got
one.
that one.
Yes,
Yeah.
that's
You heard
one
that
we've
one.
heard of.
So the mastery problem is what happens in Mario Kart if you didn't have a blue shell.
Well, you just drive like the
You mean racing games like regular ones? 'Cause
yeah.
that's Mario Kart without shells, I guess.
Sorta, but you got to think that racing games is not. I don't play Forza or Gran Turismo with my family.
True.
You know,
So would the mastery problem be the best player is consistently winning?
it means that the best. No, no, it means that the worst player can never catch up.
Oh,
Okay, so
Most games just don't implement a solution for that because for a lot of competitive games, if you're the worst player, you don't deserve to catch up.
Well,
deserve
and
is a tricky word right there.
That's what I was thinking of this when you were going over this, which is that it when you were talking about okay, are you going to make this game fair? What does fair mean? Is Mario Kart fair or is Forza Motorsports more fair?
Yeah.
Mario Kart is not fair because I'll get red shelled 5 times in a row. That's not fair.
Right?
If you throw a red shell,
but that other
out of my house.
person isn't as good as you, and they have a higher chance now of winning.
Yeah.
You have to choose what aspects of the game you want to be sort of equilibrated.
or
Equal.
I don't know if that's this is specifically what we're talking about, but you maybe have to choose in which aspect you want it to be fair, because in the point of view like Mario Party or Mario Kart, or those type of games, you want to be fair for everybody, including noobs or people that never played the game, people that has been playing the game for years maybe. So you want to be fair for them to win. And then for games that are more like competitive or more serious, you want to be more centered on like skill. So the fact that you just played it for the first time, you want that player to grow in skill instead of giving them an opportunity to win out of nowhere, I guess.
Yeah, let's think about it from what's the opposite of baseball, right? What's the opposite of this? Think about it. I'm saying that being a game designer, a designer of interaction, of actions, of systems, of rules, tilts you, thankfully, towards ethical concerns. So, in which situation would you want the game not to be fair? You said a game of skill, okay? So you would want the game to be fair only to those that can play it, only to those that can play it at a certain level. Do I need to have played another game, a completely different game, to know the culture of games before I can come and play this game? Is that fair to a person that wants to play this game? Are you eliminating the possibility of people engaging with your game until they engage with another game? In other words, are there preconditions to getting to this game? it's a deep. I'm sorry to burst your bubble here, but games is not just like I'm just making a game. Okay, leave me alone. It's not for the game designer. For the game designer, you have to consider like, okay, well, I want to play Dark Souls, or I want to play Bloodborne, or whatever. Okay, good. The game is fair. Really? Okay, how do we make it fair? Well, by it having all you need in order to play and improve. Because imagine if I said, oh, this game definitely discriminates against the blind, which it does. It discriminates against the hard of hearing, which you could say that it does. There are some telegraph moves that have to do with sound, right? So when you say, oh, the game is fair, you may be skipping a step. You have to consider these things in order for the badge of fair to be applied to it. A person being good at something is not what I am against. What I'm against is the system ignoring those implicit limitations just because the game said so. So, for example, canceling actions. Balancing is trying to affect the numbers so that the numbers don't cancel actions that I'm interested in having players explore. If I know that I play Mario Kart, and because I've played games for most of my life, I see a kid that's 5 years old, they're never going to be able to play and never going to be able to catch up. I'm canceling their ability to play well. Dominant strategies have to do with that. If I balance where the rocket launcher is so much better than every other gun, then that means that nobody's going to want to have other guns. So I've canceled the ability for people to consider those other guns or those other weapons or tools.
About colorblind.
Oh yeah, that's another one.
These can be more important than you think it is at times.
More important, look, if you say, let's make a game only, and this is where, again, games are about, but games tilt towards the player needing to be comforted or allowed to play. And since we don't know who the player is, we tend to want to include everybody rather than a select few people to play. The action of including more people rather than fewer so that it can be played better by more people rather than fewer is seemingly an ethical concern. And the more, I'll use the word, the more woke you are, the better as a designer that you're going to be able to target that requirement. And like Blue just said, I mean, his last name is a color already. Marvin, what's your colorblind version of your last name?
People with it's yellow. People with tritanopia can't see Blue. He's invisible to them.
Right. He'd just be Marvin. Look.
Yeah. Yeah. Oh yeah. They just don't see the word blue. They see.
Yeah. So, color blindness is a thing that affects in 10% ratio. It affects males. So if you were even trying to say, look, I'm going to make a game only for guys, and you ignore the situations that exist for people when they start to play your game, you've already disenfranchised or prevented 10% of your population to play as well as the other 90%. Just by that fact, by ignoring something. Now, can you know everything? No. Are you going to make decisions with a certain amount of degree of ignorance? Yes. That's part of, being alive. That's part of trying. That's part of creating.
Possible to know everything.
Yeah, but the moment
Yeah.
exactly. But the moment that you become aware of it, that's your chance, that's your choice. So, the purpose of Mario Kart. Would I rather people play driving games rather than never play driving games? The answer is yes. Is Mario Kart part of what makes, you know, trampoline into other racing games? The answer to that could be, well, it's better. It has a higher probability than a lower one.
The
The answer
gateway
is yes.
game.
Yes. So that good. Two things that are good. Can we continue to make that a streak of yeses? Right.
I think I'd like to add
Mhm.
another sort of lane to this as well, which is this is where the nuance comes in, and this is something that I've picked up from this book that I'm reading actually, which is like, so we're going over all of these ways of where you are of how a game can exclude a party of people, exclude certain individuals.
Mhm.
But as they were saying, you can't know everything, and you also cannot accommodate everybody. And so when you're designing your game and designing what fairness means and what aspects need to be fair and who you are going to try to accommodate this experience for, you also at the same time have to choose who you are excluding.
Yes.
Right? And making that choice with purpose and understanding that you are making that choice is sort of the nuance of making those decisions in games.
What book are you reading?
The Evolution of Useful Things by Henry Petrosky.
Oh, didn't I suggest that to you?
Yeah, I think.
Yeah, it's amazing. Oh my God! Tell him about forks.
He
what? Yeah, it's the best.
He isn't talking about design in this, but if you go through this degree program and read this book and don't realize that he is actually talking about design, then maybe you didn't learn an awful lot.
Yeah.
Because he's talking about invention and how engineers produce changes in objects. And he talks about in this last chapter that I read, the fact that you can only accommodate so many needs with an object.
Yeah.
Right? You cannot make the perfect table.
Yeah.
Okay. The table oh gosh, I'd have to look up the quote, but it's like a table that is scratch proof, that is also weightless, that takes up no space but houses as many as you need, that is the right height for children as well as adults, as well as different sized adults. One that also looks stylish, right? But also, when you make a decision, you're making a forked branch, right? You're choosing to go down one lane.
Yeah, he says something a lot of people say, and you got to take both approaches here. One of the things that you'll hear a lot said about design is that form follows function. And he says, well, form follows failure. And it's a lot of the failed attempts that you do at something is what makes that evolution work itself out and also create those, like Dylan said, those forks.
I was going to bring up the idea that in gaming, like trying to include everyone, or at least like as many people as you can in and of itself, can alienate people. Because if you make a game for the casual audience, you're inadvertently alienating part of the competitive audience. So even trying to include everyone is counterintuitive. It excludes people.
Well, but it's always the minority of it, and we default for, and that's the other thing. Remember, you're making for X player. Like if you were making a game for your parents, you have, everybody, as far as I know, have two parents. So if you made one for your dad versus one for your mom, well, they're different individuals. They may have the same likes, similar likes, but if you're customizing that game for one person, you're obviously excluding the other person, right? If the more that you do that. But if you're making a game for parents, now you're including both. And not just them, not the ones you know. You're going to say, well, am I making a game for my parents or for parents in general? Well, now you start to include always you always tilt towards the majority of it. You never the more exclusive that you make it, you might as well make a story. You make something that is dedicated and has little wiggle room for interpretation or little wiggle room for variety. Games tend to be about a variety of experience. They're not just like as um, if I play a game, it's like playing Pong. You play Pong as the Pong paddle, and if you only play against the computer, well, you're only going to be playing against a very specific type of, you know, uh, NPC. That without variety, it's going to be like, well, I've seen everything I needed to see. So the fact of adding more variety, which is where numbers start to show up, where those different attributes start to affect the gameplay, so that we can add variety, so that we ourselves can explore some things differently. Otherwise, if it's the one story that you're not the one story as per se, but the one game narrative, experience that you have is the same one that you're ever going to have, then you tend to not replay that experience or not even approach the game with the desire to explore things. So yes, for example, exclusionary type of design would be a game like Dark Souls, that they say this game is for people that want to have a very difficult time. Like they really have to master those patterns before they progress. And they have the time. You could say that Dark Souls first discriminates against adults. Who has the least amount of time to dedicate to a game that takes that much kind of mastery?
Adults.
You could say that
working adults.
Working adults, right? A parent, working
Important
adult.
Distinction.
Exactly. but you see how it's a matter of time, and you're now making that the majority of the balance, or how you unbalance that equation, or you exclude. But we don't want to do that anyway. We want to say adults, even if you have 10 minutes on this, you're going to enjoy your time. So mastery problem on a game like Mario Kart, which is part of the culture, is part of the you play patty cake. You're already playing part into the entire culture of our human experience of play. Case in point, what I'm trying to make here is the argument that the numbers and the act of balancing is not just like I balance the game. It's a very careful, methodical setup, that you don't do it just to tilt towards one factor. Knowing what data you have available for any attribute in any aspect of the game, whether it's the gravity factor that you use in your gravity in your physics system, okay, whichever it is, that is so that other interpretations, other access to some actions can be maximized, and you avoid the idea that a person, just by virtue of them being older or any particular data set, prevents others from, and again, being able to catch up. That's the key here. It's not whether you are better and you can maintain better. It's that others cannot. It's in a that you reach escape velocity is basically what it is. I mean, why would I play I would never be really playing tic-tac-toe against a 5-year-old. They're playing. I'm performing. They can't catch up until they can catch up. But it's fair because then they discover, that they can at least draw, and then I can never win. That becomes a better source of things. So a lot of just look at Google Sheets as that which you are going to use to guarantee certain numbers. that you're going to guarantee that the experience for it has a mathematical nature of guaranteeing that actions are all discernible, understandable. There's no black box to this. This class, when we're talking about mechanics, what a mechanic is any action or rule that, given enough intelligent observation, it can be understood. That's what a mechanic is. An action or a system that, through intelligent observation, given enough of that, it will be understood. It is not something that prevents itself from being understood, which would be like what randomness is. If you have a random system, it can't really be a mechanic. It can be part of a mechanic, but the randomness of it is just so that you can get a number. But if you're going to say that something is hidden so much behind so many layers and nobody can understand it, then it ceases to be something that players consider that they're able to as something that they're able to wield or use. So now we're going to move over to the coding part of this. And you've already seen there are videos out there on what it is that you're going to do. But this case, we're going to do a part of the code that we described, we talked about last class, like the philosophy of it. And we're going to now make some project, a small project that is about understanding how that layout of classes, inheritance, abstraction, encapsulation, polymorphism, all those things come into play with the model of the things that we have up on the cloud with Google Sheets. Okay, so FAM RPG is what I like to call this. Alright, so here we go. Namespace. Obviously namespace is so that everything is contained across different files and you can access things together. This is our main. This is just how things are. And hello world, and let's keep this Solution Explorer up so I can see it. Okay, so we're making a family. We're making our family. And we know that our family is a set of humans. We're going to call them persons. And persons are basically characters. But characters are going to have some things that all persons have, but persons might have things that characters don't have. Okay? So we can start to differentiate between them by making the inheritance model be something that we then customize down here. Okay? At a lower tier in that project, or in that breakdown. So we're going to add a file. We're going to add a couple of files. We're going to add a file. We're going to add a new item. What item? We're going to add a class, and we're going to call that class characters. Okay. And these characters are going to have things like, well, what are they going to have, right? What does a character typically have? It's going to have attributes, yeah?
Yeah.
Okay. So what attributes are they going to have?
Strength,
Okay.
dex.
Okay, so let's start. Remember what we were saying about defining them? Give them to me, but define them as well.
Like a description, or defined like in a program? Do you want me to tell you what to write specifically?
Yeah. Tell me, like you said, strength. Okay, strength is a letter. I have
an int.
A strength.
Okay, it's an int. It's an integer. It's a strength, and well, that's it. That everyone has different strengths. So,
okay.
Yeah.
What else?
Dexterity, maybe.
Okay, and define that.
It's an integer too. It's called dexterity. Cool.
Yeah, like watching paint dry. Here we go.
Intelligence, int.
Yeah, I'm gonna make an educated guess that we're gonna do the same thing for a few more stats.
Okay, well then everybody help each other.
All
Help
right,
me save my voice. Tell me what to do.
integer wisdom, integer charisma.
Constitution.
Just like my characters, no constitution. We never need it. 1 health. It's fine.
Dude, Constitution is the one of the most important things, to be honest.
Not if you're a sorcerer. It doesn't matter.
It's all about that charisma.
Doesn't matter.
Listen, I'm a fighter. The only stat I need is charisma.
Yeah, there you go.
We have characters here, and we are determining how those stats exist, and that the stats are from 0 to 4 billion. Really, literally, what we're saying, we can have charisma 4 billion because that's the size of int. Int goes from 0 to 4 billion, or negative 2 billion, which might be a charisma stat for some of my more wonky days. Two
Sounds like my
billion.
barbarian.
Yeah, exactly. You can have negative negative charisma. So, what do we do with what do characters also do? What characters here characters obviously have these things as stats. That could be enemy and whatever. Do NPCs get unique names? Sometimes. Are NPCs used in different areas? Are they used as companion characters? Well, then they get a name, right? If they're just people that you're walking by that you can't even ask a name, then it doesn't get a name. It gets a generic name. But it even would have a generic name, right? So it would be string. That would be name. Even if it's generic, we can set it to no name.
Would every
Right.
character have a level?
Maybe. Or H. We can use H instead.
Is that something that we're going to use for everybody, though? See,
Well,
we're
by
defining
default,
characters
you could-
because here. Just so that you can see. We're making another class. We're going to make another class. And all these have to be public classes, okay? We're going to make them public. So now, public class, and we're going to say person.
There you go. Okay, yeah. I understand
And
now.
person is going to be like is a versus has a. A person is a character. Okay? Let's change the name of this here. And now we know that this class person, in any method that I create, let's say public void display attributes. Okay? Character only has a method. We've defined its access level so that other people can call my hey character, hey person, please display your attributes. Well, I can go to base dot all the attributes that I have, or actually just go wisdom. Is this narrating correctly? Oh yeah, these have to be public.
Okay. So even if the class is public, the variables won't be public unless you tell it.
Look, I'm on person, and I'm accessing whatever's available there. I can literally say base dot, and that would be whatever I have from my base. I can also have another strength didn't strength doesn't really need that E. It's so strong a word that this still sounds like strength.
Strength.
Yeah.
Strength.
I love him my
Yeah.
strength.
Yeah.
Oh, I just thought of another uh shit. I just had it.
Attribute.
Yeah, another attribute. Well, it's less of an attribute, more like it's something it'll change, but armor class, so AC.
Yep. Well, those are the things that I've listed on the activity. And the activity I have AC, armor class, health, who you're related to, like what friends you associate with, the attributes, all those 6 attributes, and name and age. So those are things that let's see. Strength equals base dot strength. What's it complaining about? What's
Your character strength may be an int, and this is a float.
hide? Nah. What did I just do there? I'm sorry. What did you say? Can you repeat that, please?
I mean, is the strong that you have here is a float, but the string that you have in the really original version is an int.
Yeah.
Maybe they have a problem converting.
Yeah. I am. Oh, look at that. New float strength. Use word new. A new keyword if hiding was intended. You know what? Oh, look at that. New float. That means that now strength in here can be equal to that strength divided by 18. Okay? So notice what I'm saying here, Jelly. I have this strength which is available inside of person, and it's not available up here. But the int strength character is like what we roll for any character, but here I'm displaying it as a percentage. Do you see? So I'm saying there's a difference between my person's strength member variable versus my inherited class's base member variable called strength as well. We wouldn't want to do this with names like that. That's why we want to. This is interesting that this allows me to do that. But I'm going to say strength percent. And then there's no confusion between the two. Do you see?
Yeah.
And we can also say this here. We can say strength percentage. Or we can go to, we know what, it knows what strength is, but if in case that I had names that are similar, we say the base is what I've inherited from versus the current one that I have in the class that I'm making. Notice that I can say, like all NPCs, let's say that they all have a name, and that, but all persons have a
last name.
Yep. You see how the person now is starting to become a little bit more robust? It's based on character, but we have now given it certain functions that are unique to persons versus characters. Now, we can also say display attributes is a function that we have here, and we have another that we say public virtual void
leak.
Yeah. Display name. Display attributes. Okay. Okay.
How do you do those shortcuts, like to select and stuff like that?
How do I what?
Because how do you do those like shortcuts to select the specific part and then erase the other like you did there?
Like this? You press and hold
Yeah.
control. So this is where you start to find your own optimizations. If you press and hold shift and you move like this, it'll go character by character. If you press
Okay.
control and you move left or right, it'll go from word to word. Okay? If you
Then.
press and hold control and shift, it'll select the entire word.
Ooh.
You see?
Yeah.
Now, so this is public virtual void display attributes. This can say display, console dot write.
Oh, all right. Okay. Cool.
Yeah, write attribute attributes are okay. And we go here on public void, public override display attributes. And that means that because character has a method called display attributes, now this is no longer, let's display attribute. Yeah, sure. Thank you very much. It's functions. It's methods.
Pascal case.
Yeah. What kind of case?
Pascal.
Yeah. So we have these. Now these are interrelated. That means that there is a defined version here that's virtual so that it can be overridden in its child class. Now we haven't made any instances of these, and we just want to see what we would do. So we have that information there, and we're gonna call if we say display attributes, which one? I mean, I don't want to call it from inside of here, right? So, but I can call the base class dot display attributes. You see? If I call it from, if I call the same one here, this one here, it's calling itself. It's calling this one, and it'll go doing that forever. And if that's called recursion, by the way, there's a way to escape out of that, but not currently, and we don't want to do that. We can say base dot display attributes, and it'll display the what it'll say. It'll just do that and come back here and do that. Let's just continue on this line. So let's go here, and inside of main, we're going to make a person. I'm going to say me. Okay. Really new person. I think I can do this then. Fine. It's never used. Okay. This, what it's doing is forcing it to call the constructor, or I can pass in a different kind of constructor. Constructors are those things that actually get the thing built. For example, these right now have garbage information in them. It says int, like what's in strength. I think generally it defaults things to be at 0, but you can't guarantee that. And if you can't guarantee it, that means that if there's a problem that can happen, it will happen. So we have to create our own constructor so that it, fortunately, C# makes your own default constructor. So it's like hidden. It's basically doing this. In there, it says public so that other people can access the constructor. Character, no return type. No return type at all. Notice this is a method. This is how we know that it's a constructor. It's no need for a return type because what it's doing is using its own data and setting itself up. It's not returning it to anybody. So please understand that as one of the things that you're doing. So right now, this was hidden here. that existed in this class, but it was doing it for you. Now we're taking that out of the vault and making sure that it's out in the air and everybody can see it. A class can have as many constructors as you want. You can have a constructor that's like that. You can have a character. You can have this and say int default value. Okay, and pass in an int, and then we can say for all of these we can okay, and then we can say equal, and then boom, all of these. And say equal, all of these are equal to default value. Basically made strength equal to dexterity to equal to intelligence. I'm setting up all those values as they are, right?
Yeah.
So let's see what happens when I call the constructor when I knew it on the program over here, and I say 6. It wouldn't be person. Person doesn't have a constructor. We can't new a character because a character is not a person, right? So what do we have to do? On person, we have to make a constructor here, right?
Yeah.
And let's make it right after this here. So we say no. Public what?
Public person.
Right.
Parentheses. Open squigglies. Oh yeah.
Don't
You
forget.
have to put the parameters.
Because we're passing it so that we know to discern between the constructors. Right? So,
yeah.
And now what do we call in here?
We call character.
We are going to call simply
and value, right? Yep.
And we're going to say this. No, I don't think we can. Base? No. Equal? No. Oh man, how do we do this? That's if we're passing, if we're creating a character. But how do we?
It's public, so you should be able to use it, right?
Well, this is but it's. I want this dot. No, I can't pass in the constructor for this. I need to call construct parent class. I don't think you can do this. Oh, and constructor, no, and not PHP. C#. Calling the base constructor can you do that? Okay. Sure. Alright, I'll do that. Ooh, this looks ugly. Base, and then int value.
And then you leave that
Yeah,
alone. Okay.
that's it. So I'm calling the constructor and I'm passing that value to the as the value for the constructor in the base. Okay, so now no problem. And now I can say hello world me.display attributes. Let's save it. Cross our fingers. Run it. And it said attributes are. Here we go. Let me show you right here. Boom. Hello world attributes are, which is the base. So look, notice that since if we are understanding, and we're basing off of the last class, right? If we're talking about the philosophies of classes and why they're organized the way that they're organized for our convenience, then we know that if we have a program and we call it, look, I called it me, but I can call it Kayvon. And new person 6, this is just the value that I'm passing in so that it can call that constructor, right?
Yeah.
But I can also create another one that's like, look, like this. A public person, and I'm passing int value int s, comma. And just because we're so zoomed in, I need to make space here.
You.
Hey, listen, you know what? This is for your convenience, because otherwise I would have it like this, so I can code myself. But can you read that?
Oh, not at all. Sorry.
Yeah, so then take that ew back.
I can read it.
Take it back. Take it back. Sorry. sorry.
It's harder for me to follow along with how zoomed in you are because I can't see the rest of the code.
Yeah, it's exactly. It's good if you have your compiler and you're following along. Oh, there's a question. Go ahead.
Yeah. So, well, this is more like a technical question for Zoom, and the whole zoomed in code and stuff. You use OBS because of your crazy camera nonsense, so that you basically stream OBS as a video into Zoom. Could you just stream your face as the video so that the whole OBS thing is just for your face camera, and then use Zoom screen sharing?
Well, but on YouTube, I still want the code to show up.
That's what I realized.
Yeah.
Was it would mess with your recording of that?
Yeah.
Unless in the
It's alright. Just let it be.
Yeah. So let's keep.
I see what you've been dealing with.
So let's continue here. Let's have another. See, we have one that is based on one value, but we're gonna create another constructor. So we have two different constructors, and we're gonna pass in here. We have to make that constructor over here on the base constructor, so we can pass it. You know what? Here. We can have the combinations now became just exponential, right? We know that person has a constructor that's a base constructor, even has a default constructor that has nothing and doesn't even call the base. It calls it by default, but it doesn't call and adds any specific values to it. So we have a person constructor that now we can access it from outside because we're making characters or persons, but we're starting with persons because it's for the
parent.
Yeah, it's for the purpose of knowing that we have inherited classes. In many cases, instead of calling it character, we call it base class, and the like a base, like an attributes class or something like that. But we're saying characters because we do know that there are like main characters. We have AI controlled characters. We have NPCs. We have a family, a zoo basically of different kinds of characters that we can have in our enemy characters, etc. So it's so that you can see where we would store this and then how we can borrow from it in further classes in the hierarchy. You don't have to have that. You can make one that is purely just a single person and has all this content over there, but we're making it robust, more robust, so that you can practice that breakdown. Okay. So here we have me.
You have to change that to Kevin. Yeah.
You change Kevin back to me.
Change it back. Yeah. But it's my name. I'm gonna. You know what? I'm gonna make it capital K there. I like me too sometimes. There we go. And we're gonna save it, and we're gonna go like that.
But that's again capitulation rules. You can't do that.
Listen, I have limited power. So I have to fix this constructor here, which is that now I don't have a constructor that just calls value. Values doesn't exist anymore. And if I were to do S and all of those here, just passing the values that we receive from the call to the constructor. Okay, and now we have to find. See, it says we don't have a constructor that takes 6 arguments, so we have to go and make a constructor here, another one, that takes strength, and we pass in those. Now we pass in these. There's a constructor for this. This here. And so on. Okay? And now we say strength is equal to underscore S and so on. So there's a lot of benefit, right, to setting up our code in ways that we can then grab data from other places like Excel and make it work the way that Excel, Google Spreadsheets shows us. That way we can have all those setups of data. We can guarantee the data that's up there to be as balanced as it produces some mathematical results, because it helps us find that consistency on that, data specific solution, and then implement it here, test it, and work with it. If I wanted to then guarantee that different values require different create different results, then what the program becomes is a test environment for that data. Do you understand what that means? Do you understand the implications for that?
Yeah.
It means that you can have a family up in Google Spreadsheet or Google Sheets and make all as many families as you want, and then you come in the project and you have you're making your swinging, your running, your attack, your defense, and whatever. That's what a person's concentrating on, the actual actions of the game, right? And then all you have to do is go fetch the data, and it'll change the gameplay somewhat based on that data. And the person can continue to play, and you don't have to change, recompile anything. You just have to feed in different data. Where can you feed that data from? A file, a database, even Google Sheets itself. And there are modules for that. When you go in Unreal, there will be some solutions that you can either make yourself or download from an asset store that they have. So you can make the data over there, play with the data, balance it, unbalance it, play with it, and then make your gameplay based on that data. How fast does the typical cart in Mario Kart go? Well, it would suck if you have to hard code it in your code. It's better if you have it some database somewhere, and you fetch from the different version of the database, and your game continues to work perfectly. Do you think that they're building that code inside of the when you make a build, that you're baking those numbers into the actual exe, or you're just maybe fetching that, putting it in a file, then having that file there, and you just play with the file numbers? So acceleration didn't change. It's just how fast you accelerate. So I want you to view that as a like a production power. It's a super good skill to develop. Okay, and there, character has all those attributes done. And now when we have person and s and all that's here, we can make our own values exist. We can have person say last name on constructor is last name. Check this out. Comma, string, name. And we say last name is equal to L name. So, and we can do the same thing here. We can even have an init function. And we can make a default value here. Nobody. And then when we go to initialize and create and construct this person here, we can say, well, now I don't have a constructor that takes one parameter. It has to take two. So I can say that's my last name.
Acosta.
Not with a space, just there. Okay? And now when we say display attributes, I'm calling my display attributes. And I say console dot write line, and we say my last name. Okay, so whatever I have on display attributes plus whatever I have in here. Let's see, let's save it, run it. We go up here. Attributes are Acosta. I don't know what that means.
Yes, they are.
But notice that this part here was from the base class, and this is what the child class, the class that we're person class, is making. Now if I wanted to just print the values of my intelligence and all of that, all I have to do is come here, attributes are, and we say strength, and I can plus, there's many ways of writing this function, you know what they are. So strength dot to
the word strength again.
Pardon?
I said, yeah, you forgot to eat first. I said word strength again.
Strength.
We returned to strength.
I'm strong.
Yes, you are, buddy. Yes, you are.
So, and so on, right? strength, and we can what is it, dexterity, and I like this.
The 30 is going to display the strength actually. Up
Yeah,
there.
that's good. Good call. No. And say right line, and this one here backslash n, and backslash n, and so on. So yeah, let's save it, run it. And look what's going on. This is already printed. It's already done. I can say
zero Acosta.
I can say display attributes, and I can pass in like underscore like a int bool base include base equals true. Okay, and then go here on the program, and instead of display attributes, it's by default it's going to display and include that. But if I say false, then now I'm customizing this to only occur if let's move this here, if include base is equal to false. Sorry, is equal to true. Now save it, run it. Oh, hello. False. What's the
exception was on the other side. There you go.
What? Oh no, I need to override it. Yeah. Okay, it's not being used at all here. So now they're the same. And here I have to pass in
A value.
A value, but I also want to make this default valued, so false. So on this one, I'm setting it to true. On the default here, including it as false. Okay. So.
Okay.
But I'm not doing anything over there. I can say if this is equal to true. Right? I can say if include is equal to true, return. It'll skip out of that line, right?
Yeah.
So it's by default false, so it's gonna by default gonna go in here. Otherwise, if it's true, so what I do is if I wanted to actually false. There. Sorry, now it's gonna be correct. Don't display false, and if this is false, returns. So either way, it's gonna do that. But it really doesn't matter what happens on characters. It's just basically for the definition, for it to be the same, to respect that virtual. And then I can just ignore the rest. Anyway, save it, run it. Here we go. That was set by default, just says Acosta. False. Say true. Include the attributes. Didn't do what I wanted it to. So, oh, by default, yeah, because I said default. So, oh, yeah, this is what I'm missing here. I pass in the actual include base. There. Now it's passing the same thing in there. Save it, run it. Boom. Now it's including it. I don't want it to include it. Save it, run it. Boom. So this is a function that we've made for displaying attributes, which is what we basically have to construct and make it different, make it unique, customize how you display it wherever you make that display call happen for the characters that you're managing. Other functions that you can make on the character, you can say the character level, you can say since these are public, the child class has access to it, but I can make these private, right? And now when I construct it, they're set to it, but no one else can access it later. See, notice that person isn't using any value except for here. Where's the strength? Here, strength, because it's set to private, right? So what we would like to do is create properties. Properties, which is to make a get and set for these values here. So, for example, strength with in all lower caps. I can have a public function, it's not a function. It's a property, which a property is a way to set and get values that are under different levels of encapsulation, meaning different levels of protection, right? So I could say that public int capital S str, okay, is, notice how you set this up. You set it up as if it was a body, like a constructor for that. And we say a get and a set. The get has to return whatever value. Get is like creating a function that returns a value. And what we want to return is strength, the actual strength. Strength was set up only in its constructor phase, nowhere else. And set, I'm not allowing anybody to set it. Okay? Anyone. Okay. So I can make all these attributes for every other class, and these are attributes, or sorry, properties for. See, this one is related to that one because it's returning strength, because I wrote it like that. I could return dexterity if I wanted to, but I'm focusing on that one. I can also make a function, like a method, called public. It returns an int, and it's called get dexterity. I pass in nothing. I just say return dexterity. Nobody can see, nobody has access to its private. Maybe in this class I can, which I'm going to do when I make a function that calls level up. So see, nothing can set it. Nothing can other than a function inside of here. So when I go over here and I it'll still give me a problem. See, it'll say base strength. Well, I can't access its strength value, but I can access its str. And I can say on a person, let's say that we say have a function. Let's say that we say, yeah, that sounds perfectly constructed statement right there. Let's see. See what we see. Let's say what we say. Public level up. It's going to return nothing. Actually, you know what? It's going to return an int. Level up. It's a function, so capital everything. And we pass in, let's say, a float. And return level. Because I'm going to make an int. It's called level. It starts at 0. Int float? No. We're going to float experience. exp. And so that we know that what this is. Okay? Notice that I'm making this on the character. The character is going to return and give me a level. Okay? So it's basically like level up, add stuff, and then we're going to say get level. It's always going to be a calculation, and we're going to say that the what would be a good equation for the level, like the log 10 of a value? So
or maybe I mean my way could be more complicated or more long to make, but maybe you could get the total experience, and depending on how many experiences you have, it's a different level. If they have, for example, 100, they're on level 1, 150 level 2, and so on. I don't know. That's the way I see.
Look, we can do this. Get level gets requires a float. Exp is equal to 0. So we can say whatever, if it's a 0, then just return the level. Okay, that'll return that int. And here we say level up is going to return level. Now we don't have to capture that, get that level here. Level is a palindrome. That's pretty cool. So we have get level and level up. Okay, so
be right back.
Yeah, so let's see. Float str log is equal. Is there a math function? What kind of math functions do we have here? Math, yeah, mathf dot log 10 of exp. Okay, so that's gonna that's just basically the the power of the value that we have. If we pass in 100, we should get 1 back, right? Or 2, sorry, 2. So we can say, we capture that value, and then we say say gen level actually we need to put that in
back
here. Okay, there. So if we pass in a value, it'll add to that. So we have our, yeah, that'll just give us always 1. That's pretty cool. Let's see, display attributes, and we say console dot right line base dot gen level get level. Oh, this is on. Oh, it's right here. No base, just get level. Include false, and we say, do we want to keep experience on the character, or do we want to keep it on the person? Do all characters have experience, or do all persons have experience? NPCs have experience and levels. They have attributes, might as well. So we can get the level from whatever they possess. And what we're doing is just passing in a value of what, I don't know, whatever local value we want. But if we pass in 1,000 here, it'll say level. Let's see. Acosta, we say true. And we say level 3. At 1,000 experience points, log 10 of that is 3. 10 to the third is 1,000. Right? So we can, what if we wanted to level somebody up, we could pass it into person. Person says add experience. Add experience calls get level, and get level returns that value to us. And in the process, inside of character, not inside of person, inside of character, the function for leveling up would be the equation that you have. If you have level 3, maybe for this type of class, you would add a particular point on any one of these attributes, or however you want. Or you can say that the level is equal to the attributes that you have, and an equation on that, and it returns that. And it returns like whatever function that I have here. If I wanted to say plus gen level is equal to that plus the average of all the experience points attributes that we have, and that'll be a consistent thing. Or you can say HP is a factor of all those, if you wanted to add a point to HP from Constitution, and it'll be something that you always get, because maybe your Constitution changes, and that should change the value directly of your HP, and so on. It's a calculation that you can continue to do. So, is this making sense at all?
In a way, yes.
Not particularly.
In what way is it not making sense? This is what we need
Like
to be finding out.
specifically, what I'm not getting is the way you're explaining that the leveling up. But that's about it.
Oh, okay. So notice that okay. You know how people calculate taxes in the U.S.?
No idea. I never calculated a tax, and I don't
Okay.
think I will for a while.
Well, there's brackets of how much taxes you owe, or you have to pay, or whatever. So let's say that every $10,000 of your, this is income tax, okay? So based on your
Okay.
income is going to be how much they tax you. So let's say that from $0 to $10,000 that you make a year, and these are not the numbers, you pay no taxes, okay?
Okay.
So let's say that you make $9,999. How much taxes do you owe?
None.
Correct.
You don't know anything. Yeah.
And let's say that the percentage that we're going to tax you at from 10,000 to 19,999. Okay, those other $10,000. We're going to tax you at 5% of your income. You owe us 5% of your income. Okay.
Yeah.
So let's say that you make $10,000 on the money. You owe 10,000 times
times 5%, right?
exactly. So 5%. 5% of 10,000. So you owe what? Every 1,000 would be $50, right?
Yeah.
So it would be $500.
Yeah.
You owe $500. Okay. Let's say that you make 19,999. Okay.
Yeah.
So you make that amount, basically about $1,000 is what you'd owe. But from 20,000 to 30,000, your bracket goes up. Let's say you owe 7%. Okay.
Okay.
So I just say all I have to pass to you is the amount of money that you make per year, and
Yeah.
you return to me how much I owe. That calculation gets done inside. See, it's basically like I'm passing here.
Okay. You pass the experience. The calculation gets done inside the function or the method, and then it returns
Exactly.
the result
amount.
of the calculation. Okay.
So I never have to say, well, I pass in 10,000, then I pass in another 10,000 for that other amount, and then I pass another 10,000. No, I pass in $25,000, and you say, okay, from 0 to 10, $999, I don't tax that. At 10,000, I charge $500. Another $500 on that entire amount over there, right? And then I'm at 25, so that's another 7%. So it would be 5,000 of that amount at 7%, 10,000 at 5%, 10,000 at 0%. You get it?
Yeah.
And what I return is 0, 500, and then 7% out of that would be another amount, 500 plus, around $1,000. Let's round it around there. I don't know. Okay.
All right. No, I get it.
So that's what I return. I return the amount, and I return the tax bracket that you're in. Maybe I don't return the amount that you owe. Maybe I just at 25,000. Okay, then you're at level 3 of the tax bracket, which is basically what experience points is doing here. I pass in 1,000. I return that amount. And where I go define it is on the character level, because all characters have levels. Not all people have. People might have that, but even an NPC might have that. Maybe we have to make another one that's even more generic. Or maybe we derive NPCs from character, and then we don't give NPCs experience. And then we keep all experience on different levels, right? And we can say persons are characters, but NPCs don't, sorry, persons are main characters. And NPCs don't have another level that you inherit at that, past that. And we keep that level or experience to persons and not characters. We move the data around so long as we make a map that is effective and useful for us. So what I recommend is that you make these classes on paper first. I want my main character to have all these attributes. Oh, we have dogs in our game. Okay, do dogs have strength? Yes. They have dexterity? Yes. They have intelligence? Yes. They have charisma? Yes. They have all those. Okay, well, I guess we can make the dog a character, and it's a companion character, right?
A good example of this being used in actual games is in Skyrim. The spells are weapons.
That's a good
you
one.
equip a spell. If you think about it, the way that the game is logicking through it is like you equip a spell into your hand the same way you equip a sword in the other. It just goes into the hand, and whenever you try to use it, it just has a different effect than swinging.
Yeah.
But logically, they're basically the same.
Yeah. So a spell is a weapon. A spell is a weapon, and then all you have to work is on equipping weapon. Oh, this weapon called fireball? Okay, no problem. What's the range of that weapon? It's basically asking what's the range of an arrow, what's the range of a fireball. So this is going to take a little bit of time to go. It's going to take a little bit of practice. Set this up. Set something like this up. See where you get. This week we're doing both. We're doing the stuff on the spreadsheet. Super simple. Get those data values to combine and average correctly. That you can do on your own spreadsheet, and then you submit those values to me. And I have those values, and I don't have to check your spreadsheet. I just have the values that you created because you've tested them on your own spreadsheet and you submitted them to me. Basically as if you submitted them to a database that I'm gonna, when I make my game, I fetch from.
Alright.
And then you have another program that I made for you that you're going to enter those values that you sent to me. You're gonna enter those values, and then you're just gonna display them, because all I want you to do is basically play with that part where you're just displaying attributes, because once you display them, then you know that you can manipulate them. That's the majority of the things that we've been doing with our programs, right? Console.WriteLine, console.WriteLine. Okay, well, customize it so that it's different. I want people to have different colors. You can have for a person. We can say on our person constructor, we can say public character. We say, and you're gonna see this next week too. Private, no, not private. Public. Console color equals console dot, oh, you can't access it. Okay, just console, oh, sorry, of course, BKG color. I don't know that it'll let, maybe it does. Maybe it's just static. Okay, so we have our background color for characters are all black. Okay? And we can say foreground color FG color. And we say gray, because that's the original colors for everything. Okay? But persons, on our constructor, when we display stuff, right here on display attributes, we're going to say we're going to say from here, console dot background color is equal to base dot bkg. Okay, and fg foreground color. Okay, so it's going to set it up based on whatever's on the class, on the parent class. But on my constructor for a person, since I know that I am a person, I'm going to set up, no matter what, on every one of these, I'm a person. Okay, well, my background color is going to be, I don't know, magenta. So bkg color is equal to console color dot magenta. If I derive another class from character, their default character is colors are going to be black background, gray foreground color. So if I had a companion character on my constructor, I would make this different so that I can always display, whenever it displays, it calls its display attributes, it's going to get whatever the constructor set it up as. Okay? So now that I know that that happened, no matter what function I called, no matter what constructor I called, save it, run it. There, it's a character. If I have another one, let me show you this why this is really cool. Let's say we have a public class NPC. And on its constructor, all this NPC is going to have its public NPC. Oh, you know what? No. Character. That's it. I guess I have to have a public override this one, but I don't really I don't want to set up any of that. I just want to say I'm not going to pass in anything. And I'm just going to say, hi, my name is Robert Paulson. And I'm going to pass in false. That's it.
Fight Club.
I think so. And I'm going to say, I'm going to make another instance here. I'm going to say NPC Bob. I'm going to say new NPC. And I'm not going to pass anything. It's just the NPC. Oh, did I not make this in the right place? Oh, this is incorrect. Yeah, it's outside of here. Here we go. I can derive off of person, by the way. Let's try that. No, but then the colors are going to be the same, right? Because that's there. And we're going to say bob.display attributes and pass in false. What's going on here? Unassigned. That's why I did this then. Oh. Console dot background color is equal to base dot bkg there. Here we go. My name is Robert Paulson, and I can say NPCs have a different color. Where do we go? On the constructor, it's going to be about base dot there public NPC base dot console bkg color is equal to console color dot gray. G color. Okay, save it, run it. There's no black foreground. Okay, then yellow. None of that. What's going on? Oh. Foreground color.
And just because it's popping into my head while he's doing this, he's using colors to differentiate things inside of his game right now. And so if he were to, say, make one of them have yellow text with a blue backdrop, what if somebody is colorblind and can't see the color yellow, and instead their eyes replace that with a blue color?
There.
Right? Makes it really illegible for them. So this would be a point as a designer when you're making something that you consider, oh, maybe I should consider more carefully the colors I choose and such.
I can even say true, always display this. And look, one character, another character.
Can you zoom in on the console there? There we go.
So, look, just play with this. That's all you gotta do. The concepts of the class, the breakdowns, we already did the last class. Oh, that's rain. So now, all we're trying to do is display, use that data, the member variables, their definitions, the member methods, the definitions, the class definition, using different classes based off the same thing. Okay? Using different levels of access so that we can control the information. And I don't require that you grok it. Okay? Look up that verb. It's a cool one. I want you to practice it. That's it. Practice it 5 times. Take the same program, put it on one screen, copy it over on the other side, see what you did, change the value here and there. It broke, okay, change it back to whatever else you need. All the code here is extremely simple. I've used names that you don't need to have it commented. It's the same word, right? So you know what these are. All the code is going to be and this video distributed. And I want you to like approach it that way. Because once you get that data that's in there and you can play with it, know what to change, how to change it, and how to display it or use it, then the concept becomes ubiquitous. Now you can implement it in different systems, in Unreal, Unity, anywhere else. It's much like the things you learn when you're in grade school are things that you tend to apply later. So how to add, how to subtract, how to multiply, how to divide, all those things you continue to, whatever number, it doesn't matter what it is that you know you can do that. So the same thing here. When you start seeing these values more in a holistic way, then you'll see it in other systems how they implement the same type of approach. It's really cool. So, any questions?
And it can be questions not even related to what he did today, but just general coding questions, assignments,
Yes.
Visual Studio, life advice. It could be life gurus.
Well, I actually had a question about the quizzes, and what can I reference for quizzes, or to make sure that I learn the things that the quizzes are going to cover?
The Tony's class.
Oh, so they are from the
Okay.
previous class. Okay, yeah.
Oh yeah, for sure. Like everything that we put in there was vetted and checked for by what Tony has said. Other teachers have heard from Tony's class, and honestly, a lot of those questions are very, like, if you're looking for answers to questions that are somehow in in YouTube, not YouTube, in Google, don't just type in whatever you think and press I'm feeling lucky and then hope that the answer shows up. Okay? A lot of those questions are meant for you to synthesize what's going on. Some of them may be literally said to you in these classes. Take notes. Important that you take notes. You don't take notes, really can't help you. You got to help you. So that's what notes are. Your notes for you, to help you. And they may help others too. But that's what I want you to take notes. I want you to do, take notes. Past that, look up code, look up code references. Type C#, int, C#, switches, C#, arrays, C# anything, loops. You'll see it. But it may not be the first thing, and you may not have trained your Google to answer a lot of your code questions. Trained is a hard concept here to swallow, but it's the idea that if you're searching constantly for you know, some type of acronym that is game related, and you know that acronym now shows up on like int. If you type int and the first link that it sends you is to D&D stuff, yeah, that may be one thing. But if you have been searching a lot for code stuff and the first thing that shows up is integer, then you know that you've been making the search engine kind of customized to what type of results you want.
And I haven't reviewed this sort of test for this class. I don't know the specific content on them, but I do know about this nice app called Learn Solo. And from what I understand, the tests are probably fundamental C# programming questions. And this app just takes you through little simple modules and just goes through all the basics and then makes you finish lines of code by just typing in a few things. it's, I mean, really good even if you've programmed in C# before, just as a refresher.
Yeah.
They have it on Apple and Android, so.
Try to keep in mind that the purpose of a lot of what we teach here is to accelerate your wisdom and practice into something. The resource and references that you're going to find are going to be way more numerous than anything that I can give you in 3 hours in a lecture. So it's practice, encouragement to discuss things with others, encouragement to try different takes, some type of assignment that can help you construct things that we've seen that people lack in many areas. So go with that. Project classes, my philosophy, my take on them is that they're grab some information that you've learned and you're going to put it to a project that you're going to build. Okay? You're supposed to have enough leeway to play with a lot of stuff in there. It's a great thing to be able to play. You can only play if you don't feel like it's survival. Okay? So tests aren't typically survival because there's not a lot of play in there. They are typically survival. It's like, oh, I gotta show that I know this. But that's what the projects help. They help construct that. So what I want you to do in these projects always is first achieve what the project set out to do. Guarantee that. Oh, you're done with that. Good. Photograph that, back it up. Okay? Make another project. Go for broke. Go long. Go crazy. Make it. Break it. Okay? That's where the learning's happening. That part. The other part is just demonstrating that you're taking notes. That's it. Your synthesis is where you get to play and try stuff new. And you deliver that to us, we're like, oh my God. Thank you for making this super easy. You've taken the concept, extended it past the point of me knowing that you get it. It's like, all right, easy. We like it. We like our job to be easy. But it can only happen. We don't like our job to be easy when you're not demonstrating that you're trying. So that's what we're trying so much to get you to play with it. Play with it. Once you're playing with it, man, our job's easy. Our job is to inspire you to get you to make it easy. That's really what our job should always be. That's what we're here. I said it before. I'll say it again. We're not your opponent in the ring. We're on your corner. But we're also going to be in the gym saying, okay, hit here, hit here, hit here. Nope, do it again. Hit here. No, you're not doing it right. Do it again. Let's do it again. We're always going to be on your corner like that, but we're going to have some requirements too. Okay? You have to do push-ups.